Hello student, today I am going to discuss is nothing but a plum pudding model, then the Rutherford model, because the last class we discussed regarding the subatomic particle and the charge, their mass, like that. So let us discuss the plum pudding model. So in plum pudding model which is proposed by J.J. Thomson. In plum pudding model, you just understand what they told. They told, J.J. Thomson told, in the center of atom there is a positive charge somewhere, and around the atom there is a electron will be there which is carrying negative charge, and then this negative charge will be balanced from the inside of the positive charge. This is nothing but a given by J.J. Thomson, plum pudding model. You know very well from the 10th standard. And now this after that this model was a failure, not able to explain the stability of the atom. Then the Rutherford, the scientist Rutherford proposed the atomic model. Just I will discuss in a brief manner, then you can know very well. He did one experiment, alpha scattering experiment. Alpha particle is nothing but a what? Helium nucleus. This is a helium nucleus. From the helium, if you remove two electron if you remove, then we will get 2 proton and there will be 2 neutron in the helium. This is nothing but a alpha particle. When this alpha particle is nothing but a positively charged particle, this is a positively charged particle. With this alpha particle, he take a very thin gold foil and he strike the alpha particle in a gold foil. Like that, there is a gold foil will be there, and backside here the alpha particle is moving, maybe gold foil we can draw like this way. This is a gold foil and there will be like this scenario, and this is backside zinc sulfide skin will be there where the alpha particle can make an image. And now from the source they are putting, this is a source, they are going the alpha particle, and now maximum alpha particle either very little deflections or go straight away. Out of 20,000 alpha particle, only one alpha particle goes straight and take 180-degree angle and then take the U-turn. So now from these observations, what Rutherford conclude? The Rutherford conclude the maximum part of the atom is a vacant, or very small part there is a positively charged, some particles will be there, or positively charged but substance will be there. That is why the alpha particle is a positively charged particle which is exactly take the 180-degree angle and then taking the U-turn. Out of 20,000, one alpha particle. So that is why he proposed like this scenario, maximum part of the atom is a vacant, and then very small portion is there where the positive charge is located, and then that is why maximum alpha particle will go with slight deflections, more of the alpha particle will go without any deflections. From there he proposed these things. And later on we came to know the radius of the atom, if it is 10 to the power minus 10 meter, then the radius of nucleus will be around 10 to the power minus 15 meter. Later we came to know, not from here. Now he proposed the Rutherford, their nucleus, there will be positively charged particle around the nucleus, electron moving in a circular path. This is proposed by the Rutherford. But the question is, if you look at, if I told you one story, suppose if I start moving here whole day continuously, slowly what will happen? I will lose my energy. Then what will happen? I will fall down over here after certain time. Likewise, when the electron is a charged particle, if it is continuously moving around the nucleus, it will start losing its energy. When it will start losing its energy, the radius slowly start decreasing, and then slowly it will come and falls down in the nucleus. That means the structure of atom, what is proposed by the Rutherford, was a total failure, because otherwise there will be no structure of atom, but in reality there is a structure of atom is there. So that is why this model was failure. Then the scientist, the Bohr, Niels Bohr, around 19,500 came into the picture to propose his model. So before going to the Bohr model, we need to know certain things like that, what is electromagnetic radiations, what is wavelength, what is frequency, all those things we need to know. Then only again we will come back in a board model. So now let us first need to know what is electromagnetic radiations. Any object in this world or in this cosmos, constantly they are radiating some radiation is coming from every object, and the nature of that radiation is a electromagnetic in nature. Even the light is a electromagnetic radiations. Because why it is called as the electromagnetic radiation? It has a two component. So electromagnetic radiations has two component. So light itself is a electromagnetic radiations, and electromagnetic radiation has a two property, wave property as well as particle property. Wave property and particle property. When they will propagate like a wave. When they will interact like a particle. So that is why electromagnetic radiation has a both properties, wave properties and particle properties. Why they are calling the electromagnetic radiations? Because when they are propagating, they are like a wave. Suppose if you look at, this is the thing what I am telling over here like this. Suppose this part, this shadow part is a electric component, and which is not shadow part, that is nothing but a magnetic component. This is a magnetic and this is a electric, which is perpendicular to each other. That is why the electromagnetic radiations is nothing but a composed of a two component. One is the electric component and one is the magnetic component, which is perpendicular to each other, and they together they are propagating. And electromagnetic radiation has a both property, wave property and particle property. When they will propagate, even they can propagate in a vacuum. When they will propagate, they will show the wave property. When they will interact with some object, they will show the particle properties. And now you need to know this entire electromagnetic spectrum. What is that? Before going to that, you need to know few things. Suppose this is, I am telling the wave. The distance between the two crests, this is called as a crest. Distance between the two crests, or this is called as a throw. This is called as a throw. So distance between the two crests or the two throw, we call it as a lambda, is nothing but a what? Wavelength. This is nothing but a what? Wavelength. And the number of wavelength or the number of wave passing through a particular point in a per second is called as a frequency. And then the relations frequency or will be equals to C by lambda. This is a relations. This is called as a frequency. This is called as a frequency. And where the C is nothing but the velocity of light. C is nothing but a velocity of light. Velocity of light. This is nothing but a 3 into 10 to the power 8 meter per second. This is nothing but the velocity of light. And the frequency and wavelength is inversely proportional to each other, because C is nothing but a constant, velocity of light is a fixed. So then if the frequency is more, then the lambda will be less, wavelength will be less, or the frequency is less, lambda will be more. This is the relations. You have to remember always. N number of things you have to do with these relations. So that is why when frequency will be more, wavelength will be less. Another things, you need to know what is the wave number. Wave number is nothing but a 1 by lambda. 1 by lambda is denoted by nu bar, which is called as a wave number. Which is called as a wave number. Now, once we know these things, then we need to know entire electromagnetic spectrum. What is the order of this entire electromagnetic spectrum we need to know. So let us focus the entire electromagnetic spectrum. 2017, they put one questions on this electromagnetic spectrum. You need to know entire electromagnetic spectrum. So let us focus on that entire electromagnetic spectrum. So then this electromagnetic spectrum, if you look at, then you just need to remember these things. What is that? That cosmic ray, gamma ray, X-ray, UV visible region, then IR, then you need to know UV, all those things, microwave, radio wave, everything you need to know. So then I am writing like this, cosmic ray, and then next one is gamma ray, this is gamma, sign of gamma, gamma ray, X-ray, and then UV, and then visible region, and then I am writing IR, then I am writing microwave, IR means infrared, microwave, and then radio wave, and the radio wave last will be there FM. You know all those things. So then from these things only you have to remember cosmic ray towards the radio wave, wavelength is increasing. Wavelength is increasing. So then when the wavelength is increasing, these directions, what is increasing? Wavelength is increasing. Then frequency will be what? Decreasing. So that means you have to understand cosmic ray towards the radio wave, wavelength is increasing. Of the this is nothing but an entire electromagnetic spectrum from cosmic ray to radio wave. And now this wavelength is increasing from cosmic ray towards the radio wave. Wavelength increasing means what? Frequency is decreasing. So that is what we can write down, or frequency is decreasing. Frequency is decreasing. That things we will come to know from electromagnetic radiations. And now we need to know Planck's quantum theory of radiations. What is that? The Planck's is telling like that whenever any object either absorbing energy or emitting energy, so then the energy absorptions or the energy emission will happen in the packet of energy or the bundle of energy, that is called as a Planck's quantum theory. So then from there Planck's quantum is telling like that the delta E or the emitted energy, if I say E, will be equals to h nu. That means whenever the energy will be released either in form of a 1 h nu or 2 h nu or 3 h nu or 4 h nu, like that. It never be, it will be always emit or absorb like this, but it never be not like this, not like this, it will never happen like this. That means the energy absorptions or the energy emission, it will happen in a discontinuous fashions. And moreover, if I write down this is for only one photon, if I generalize, we can write down n h nu. E will be equals to n h nu, where n will be equals to 1, 2, 3, 4, 5, any whole number. So that is why these things proposed by the scientist Max Planck, and this is called as a Planck's quantum theory of radiations. So that means when the energy will be absorbed or energy will be emitted in the packet of energy or the bundle of energy, that is called as a quanta. So now the energy will be absorbed or emit either in form of 1 h nu, 2 h nu, 3 h nu, 4 h nu, but never like half h nu, 3 by 2 h nu. So these things you have to understand. Now you look at these things over here itself. Then if you look at where the n will be equals to 1, 2, 3, 4, 5, any whole number. Now you have to understand these things very clearly. Once you understand this point, so then you have to look at the things. Here energy is directly proportional to frequency. Why? Because this h is a Planck constant. H is a Planck constant. And this value will be equals to 6.6 into 10 to the power minus 34 joule second. So that means when the h is a constant, then energy is directly proportional to what? Frequency of emission or radiations. So that means from here itself we can write down when the wavelength is increasing, frequency is decreasing, that means energy will be decrease. That means energy will be decrease. They put a questions over here. They are giving the 4 options like cosmic ray, UV, visible region. Which electromagnetic spectrum has the highest energy? So then immediately once you know the entire electromagnetic spectrum, you know cosmic ray towards the radio wave, wavelength is increasing, frequency is decreasing. So this direction frequency decreasing means this direction frequency will be what? Increasing, wavelength is decreasing, frequency will be increasing these directions. Immediately you will come to know. So that means frequency increasing means what? Energy is increasing. So that is why cosmic ray has the highest frequency. That means cosmic ray has the highest energy. That is why they put questions, which of the following electromagnetic radiation should be more penetrating, More penetrating means which has a more energy that can penetrate more. That is why the answer will be which one? Cosmic ray. So that is what you have to understand, this electromagnetic spectrum and then Max Planck's theory of radiations. Once you came to know these things, then the two things you need to know very brief manner. One is a black body radiations, another one is a photoelectric effect. Because the particle property of a electromagnetic radiation is proven by these two phenomena, as well as energy is a function of a frequency or the wavelength, not the intensity. That can be proved by this black body radiation and photoelectric effect. So then if we focus on this black body radiation, what is black body? The black body radiations, they did one experiment. Black body radiation. Black body radiation means, what is that, my dear? Black body radiation is nothing but that things. The black body radiation is nothing but that things. The object which can emit or radiate the wide range of wavelength or frequency. That means it can absorb or it can emit any frequency of radiation. So that is nothing but a black body. And now this black body, what will happen? When you look at, for this black body radiation, they did one experiment. They take a one iron rod. This is a iron rod. Suppose you look at, this is a iron rod. And this iron rod, they are heated with some instrument. They are heated. Slowly they observe the color change they observed when they are heating, increasing the temperature. What the color change they observe? The color change they observe first initially red, and then this will be the blue, and then this will be nothing but a yellowish, and then finally it will be nothing but a white. This color change they observe. The red, blue, yellow, orange, like that, the color change they observed. And now if you look at these things, I hope you know VIBGYOR. VIBGYOR everybody knows. VIBGYOR everybody knows. So this will be red, yellow, and finally this will be blue. This will be blue, and this will go like this. And you know VIBGYOR. This is the VIBGYOR. And then V for what? Violet. Everybody knows. I for indigo, and B for blue, and then G for green, O for orange, Y for yellow, and then R for red. These things everybody knows. This is nothing but a VIBGYOR. And this VIBGYOR, only one thing you have to remember, down the group wavelength is increasing. Wavelength increasing. That means the red light has a highest wavelength. The red light has a highest wavelength. That is why in a traffic signal they used to put a red light. Why? When any vehicle is coming from the long distance, they can see there is the red light is blinking over there. So that is why because this red light has a highest wavelength, it can be seen from the long distance. That is why they choose the red light. Got the point? So that is why in the VIBGYOR, down the group, the wavelength is increasing. That means we can say, or we can say frequency is decreasing. Frequency is decreasing means what, my dear? Or we can say energy is decreasing. Energy decreasing. Why? Because the frequency has a direct relations with energy. The wavelength is increasing means frequency is decreasing. Frequency is decreasing means energy will be decreased, because energy is directly proportional to frequency. So that is why when they are hitting this iron rod, if the energy, classical physics, that means the Newtonian physics, if you follow, they will say that the energy is proportional to intensity. If energy is proportional to intensity, then color should not change. But when they are heated up, the color changing from where? Red to yellow, yellow to blue. So that is why when the color is changing, obviously the frequency should be decreasing, because wavelength is increasing means frequency is decreasing. That is why from this experiment they proved that the energy is a function of frequency, not the intensity. Energy is a function of frequency, not the intensity. So from this experiment, then we had to focus the photoelectric effect. In the photoelectric effect, what they told, already everybody knows, when there is a certain frequency of light fall on a metal surface, from the metal surface the electron will be ejected. That is called as a photoelectron. Also you have in physics. But you need to know few things over here. From here they used to put a problem on the photoelectric effect. So if you look at the idea, so the idea is to like that they will take one complete circuit they will prepare. Suppose they will take one tube over here like that, and they will take over here metal rod. This is a metal rod, and then this metal rod is there. Here there will be one collector. This is nothing but a collector of electron, and these things and this metal rod they will be connected with battery. This will be connected with battery, and now here from here the light will be with certain energy is nothing but H nu. The light is composed of a tiny particle which is called as a photon, and the photon energy is nothing but H nu, where the nu is a frequency, H is a Planck constant, value is 6.6 into 10 to the power minus 34 joule second. When that light is striking the metal rod, then the electron will eject it from this metal rod and it will come towards the collector. Here there will be ammeter will be there, and from this ammeter when the electron flow will be there, then the opposite direction current flow will be there. From there they used to measure the current, and this is nothing but because of this photoelectron, and the current will be generated. So this is nothing but the basic idea. And now if you look at, there is a metal surface is there. This is a metal surface. When this light is coming, light is nothing but is composed of a photon which has a energy of h nu. When it is falling on a metal surface, is ejected the electron from the metal surface. This is called as a photoelectron. It is called as a photoelectron. The photon is ejecting the electron, so that is why photoelectron. Now when the metal surface the electron is ejecting, there are two parameters is there, because the electron in a metal surface they has a attraction by the metal nucleus, that is called as a binding energy. You can not easily knock out the electron. First you have to overcome the binding energy of electron to the nucleus, then only can electron will comes out to the surface, and the rest of the, if any excess energy will be there, then what it will do? It will increase the kinetic energy of the ejected electron. That means the photon energy h nu will be equals to the binding energy of electron. B means binding energy of electron plus kinetic energy of ejected electron. That means two work it will do. So whatever the photon energy you are supplying, what it will do? First it will supply the binding energy of electron to remove the electron from the metal surface. After removing, what will happen? This electron will get accelerated, and that is called as a kinetic energy of the ejected electron. Now this binding energy of electron, they will be given by h nu 0 plus kinetic energy. If the mass of electron is m, velocity is v, you know half mv square. So that is nothing but a kinetic energy. And now this nu 0 is called as a threshold frequency. This is called as a threshold frequency. That means the minimum frequency which is required to remove one electron from the metal surface, that is called as a threshold frequency. The nu should be greater or equal to nu 0 to effective removal of photoelectron, effective removal of electron from metal surface, That means the nu, the frequency of the photon, striking photon, or frequency of the light should be nu which is greater than or equal to nu 0. That means the frequency of the binding energy of the electron. So that should be greater or equal to nu 0. That is why this is called as a threshold frequency. Then only it will able to remove the electron. Now when this is effective removal of electron from the metal surface, then only this will happen. After that, if any extra energy is there in a photon, what it will do? It will increase the kinetic energy of the ejected electron according to half mv square, half into mass into velocity square. So then once you understand these things, then here they observe this plot, and then also they conclude that fact energy is a function of a frequency or wavelength, not a intensity. What observation? They make a plot. here suppose the number of ejected electron versus frequency plot. If we observe, the plot will be like this. Now this is for lower intensity, and now higher one will be nothing but a higher intensity. This is a higher intensity, lower intensity and higher intensity. So that means the number of ejected electron which is coming out because of this frequency. So that means if you compare the number of electron, whenever the intensity is low, number of ejected electron will be less. But when the intensity will be more, the number of ejected electron will be more. But their kinetic energy will be same. So that means intensity, if you look at, has no role to increase the kinetic energy of the electron. Moreover, if we observe another plot, suppose if you observe another plot, then you will get the clarity. Suppose this is a kinetic energy of ejected electron versus frequency. If you plot these things, this plot will be like this. That means when the frequency is increasing, kinetic energy also increasing, frequency is increasing, kinetic energy also will increase. You look at, frequency is increasing, kinetic energy also increasing. That means the energy is a function of a frequency. Likewise, they plot with kinetic energy of ejected electron versus intensity. Then they observe the plot will be like a parallel to x-axis. That means the intensity has no role to increase the kinetic energy of the ejected electron. Moreover, here what is happening? The lower intensity means, you can think over it, the energy of the light is same or the frequency of the light is same, but the amount will be different. Suppose one torch light and one halogen light, both has the same energy, only the amount will be different. That's all it is. So whenever the lower intensity light is there, frequency is same. Higher intensity light, frequency is same. That is why the number of ejected electron is different. But the ejected electron kinetic energy, both the cases will be same, because intensity has no role to increase the kinetic energy, because the kinetic energy ejected electron versus intensity parallel to x-axis. Whereas kinetic energy of ejected electron versus frequency, whenever the frequency will increase, energy will increase, the kinetic energy of the ejected electron will increase. So that is why from here also they prove these relations. Energy is a function of frequency, not intensity. Energy is a function of frequency, not intensity. This is also proved by photoelectric effect. The metal which has a more electropositive in nature. So like that, suppose if you compare sodium, potassium, cesium, which will be easily show the photoelectric effect? The cesium. Why? Down the group, number of cell will increase, size will increase. As the size will increase, the force of attraction to the nucleus will be less. It can easily lose the electron. Electropositivity will be more, metallic character will be more. As the metallic character will be more, ability to lose the electron will be very high. So that is why which can easily lose the electron, that can easily show the photoelectric effect. So that is why the down the group metallic character will increase, ability to show the photoelectric effect, that one also will increase. Moreover, with these relations, they used to give n number of problems. This is also they used to call as a work functions. H nu 0 is called as a work functions. So these are the basic things you have to understand. This is nothing but the black body radiation, photoelectric effect I discussed. Now the next class I am going to discuss is nothing but we will start with the Bohr atomic model. We will discuss energy, radius, and what are the limitations. Everything we will explain. Thank you very much. Thank you all.